and we are here today for training on hydrocarbon refrigerants. And we're going to look at using R290 and R600a in light commercial refrigeration equipment. We're going to go over a few different topics today. We're going to look at legislation, why manufacturers have chosen to use natural refrigerants, the compressor changes, and then also the similarities between these compressors and the systems, how to stay safe when working on these systems, and then look at an actual compressor replacement. New legislation. You'll notice on the slide, on the left side, it says California Air Resources Board. When this all started back in 2017, the EPA SNAP program was going to ban certain refrigerants, such as the ones listed on the screen here, R134a, the R407s, ACNF, R404a, and R507a. But they ended up being taken to court by some of the refrigerant manufacturers. The refrigerant manufacturers did not want them to ban these gases, and it was decided in court that the refrigerant manufacturers were correct, and the EPA was actually shut down from using the SNAP program to ban these gases. The deciding judgment said that the SNAP program could only be used to bring new gases into this industry and not to deregulate current gases. What ended up happening is some states like California and Washington, and even full countries like Canada, have stepped up to go ahead and implement these bans since the EPA was not able to. So we'll look real fast at some of the refrigerant characteristics before we jump into the specifics of the bans. If you look at the chart, you can see the different classes of refrigerant, Class A and Class B. You have Class A, which is low toxicity. You have Class B, which is high toxicity. The refrigerants we'll be talking about today are Class A. They are low toxicity gases. Some Class B examples might be like ammonia or R123. The other thing that's different about these refrigerants is that they're A3. So you can see on the screen that A3 is a highly flammable gas. Most of the refrigerants that you're used to using the HFOs, HFCs, CFCs, HCFCs, all of these are A1 gases. So we're not used to working with flammable refrigerants. Some of the new gases outside of the flammable refrigerants we'll talk about today fit into the A2 class. But either way, all the new refrigerants fit into a class of flammable refrigerant. On the next chart here, we're looking at the state of California. California, like Washington State and Canada, is one of the ones that has come along when the EPA was shut down from their ban, and they went ahead and banned the refrigerants just at a state level. So what we're looking at on the left side of the chart is the banned substances, specifically R134a and R404a. And if you look at the GWP, the global warming potential, R134a has a global warming potential of 1,430, and R404a has a global warming potential of 3,920. And what this means is that they can be 1,400 times or 3,900 times potentially worse for the environment than CO2. CO2 is our baseline gas with a global warming potential of 1. So what the EPA decided to do originally, and then the states followed up and decided to do themselves, was to move to gases with a lower global warming potential. So if you look at the right side of the chart, you can see some of the potential replacements. So R450A, 513A, 1234YF, 600A, and R290 are all potential replacements for R134A. R450A and R513A both have a GWP at 600 or greater, and we kind of refer to them as interim gases. These will probably not be permanent, as they'll end up being banned just as the others have. But where the industry really decided to head was to look at gases like R600a and R290 because the global warming potential value is so low. Now if we look at R404a, the potential replacements are R448a, R449a, and then R290. So again, we have R290 down there in the category of A3. And when we look at R448a and R449a, they still have very high global warming potential. R448a and R449a are not going to be your final outcome refrigerants. They're likely to just be interim refrigerants that we use in the meantime as we bridge the gap from what we used to use to full-time flammable refrigerants. Those gases will likely be banned very quickly by states like California and Washington. They're also not exactly drop-ins in the same way that 513A is for 134A. So those have restricted envelopes because they have different temperature characteristics than 404A. Finally, if you look at the chart, it'll show the dates of when California implemented these bans. They first started with the top three here, such as supermarket systems, on January 1st of 2019. And the final ban will be vending machines on January 1st of 2021. So what this means is all these gases cannot be used for new systems by these dates. What a new system means is that if a system is brand new, or even if a system has to be expanded and the refrigerant charge is changed, they can no longer use any of these banned gases and will have to move to the new gases that we're using. So this largely means new equipment, since you can't take R600a or R290 and retrofit it into old equipment. So we'll need to have new equipment out there for anything that is being newly installed or is being worked on or upgraded. Finally, looking at Canada. Canada also is very similar if you look here at the chart. It has the same gases with the same interim gases and the same final outcome gases. Everything's very similar and we're moving in the same direction, which is the lower GWP gases. The difference with Canada is they went ahead and included more equipment in their ban. So looking at the equipment chart here, you can see things like chillers and domestic refrigeration equipment is also included, and the date is a little bit further out. So for some of that equipment, it gives a bit more time for the manufacturers to figure out what gas they're going to go to. Another reason that some of the manufacturers moved towards flammable refrigerants is in 2017, the DOE energy standards came out, and they had very high new limits compared to what they were in 2010. An upright glass door freezer, for instance, needed to be 57% more efficient or consume 57% less energy in 2017 to meet those standards than it did in 2010. And for a horizontal solid door ice cream freezer, we had to be 53% more efficient or consume 53% less energy than we did in 2010. But now they needed to look at the entire system. So the entire system means things like the compressor, but also things like the refrigerant, as well as ECM motors and LED lighting and anything else that they could do to squeeze more efficiency out of these systems.